Hello everyone, today we're going to talk about the new update of the AI lip sync model, MultiTalk. Previously, we've used this talking avatar framework with Wan 2.1 as an add-on feature for the Wan 2.1 AI models to create lip syncs for our AI characters. I've mentioned this in previous videos so you can check those out. One is called MultiTalk ComfyUI Wan 2.1, which covers the basic features, and the other is ComfyUI Wan MultiTalk Video to Video, where we use existing videos as input reference for MultiTalk. Today I want to discuss the new update of the Wan Video Wrapper, which now supports multi-audio input. We can redefine the characters used in the multi-audio input here. This workflow was created by my friend Manu Lee. He does a lot of amazing stuff and uses talking avatars like magic. Originally, this workflow uses Quen generations and Chatterbox to generate voiceover script and audio. It goes through the WAN Video Wrapper in the final steps to produce the talking avatar video like this. His goal with this workflow is to create content for podcasts or scenarios where you have 2 or 3 AI-generated characters. Using the Chatterbox TTS, it generates audio. The new MultiTalk node update, it allows up to 4 characters. Here, we define them as speakers, each with different voices. Now, let's dive into how to set this up locally or on cloud GPUs. One thing to note is that this podcast generator is already posted in the Mimic PC Discord. It's shared in Workflow section. He named it the Ultimate Talking Avatar, and it's designed to run on Mimic PC servers since some language models like Quen 3 and Chatterbox TTS are optimized for their server. That said, it should also work on other cloud GPUs or locally. For my local setup, I've made a few adjustments. I'm using Ollama to generate the context for the audio script, relying on predefined messages for the system. Here, we define speaker A and speaker B for the conversation, and it generates the dialogue script text. Once we have the script, we bring it to Chatterbox text-to-speech. Speaker A and speaker B prompts serve as reference audio, which is the concept of voice cloning. For example, I used a 12-second voice sample for the female character and about a minute-long sample for the male character. Both samples represent their respective speakers. Now, the Chatterbox Dialog TTS is a modified version from him, which we discussed in Discord. The original ComfyUI Fill Chatterbox doesn't support this. If you scroll down in this original ComfyUI Fill Chatterbox custom nodes, you'll only find 2 types, Chatterbox TTS and Chatterbox VC. I've talked about these in previous videos, but they aren't enough for handling multiple people in one conversation. When dealing with multiple conversations, like 2 people speaking simultaneously, we need to customize the Chatterbox custom node slightly. He created the Dialog TTS node, which is available in his forked repo of the Chatterbox custom nodes. Scroll down to his version of the Chatterbox custom nodes, and you'll see explanations of what the Dialog TTS node does. It handles multiple speakers and generates long contexts, dividing them into chunks in Chatterbox TTS. Generating over 2 minutes of audio won't be an issue. Once you update the Chatterbox Dialog TTS via his GitHub project page, you can use these custom nodes in ComfyUI. After generating your audio files, another tool called Speaker Diarizer isolates different speakers based on their voices. Here, you'll have the overall length of the audio file output from Chatterbox, but we need to take one more step, running it through the Speaker Diarizer to separate the speaker audios. Within those different speaker audios, it identifies the timeline and length in the whole audio time frame, such as when speaker B talks or pauses and when speaker A continues. It also marks down the speaker dialogue, noting who speaks and for how long. I'm showing that here. It really doesn't matter if you don't want to see the text. The key point is that we've divided the 2 speaker audios separately based on their voices. These 2 voices can now integrate smoothly with the MultiTalk talking avatar framework in the Wan Video Wrapper. As you can see, the latest update of the Wan Video Wrapper in the GitHub repo main branch was released last week. It supports MultiTalk and includes GGUF quantization for the model loader. This is pretty cool because it allows us to experience AI models with the wrapper custom nodes. Once you update the Wan Video Wrapper, you'll have support for GGUF quantizations and normal safe tensor files. You can select either option, and the other connections remain the same as I've mentioned in previous videos about MultiTalk. I've briefly gone over how it works and what to connect. One difference is in the MultiTalk Wave 2 VEC and batch, where we're now connecting two audios and the reference target mask. For the reference target mask, I'm using the audio length and defining the number of frames in this math node. Once we get, say, 693 frames to generate in this node, we pass that number of frames here and then go back to the audios, where we'll have two audios. Therefore, we need an image representing two people. I'm using segmentation, the segment anything tool, to identify the two people in the mask area and then separate the masks. We're using this node here, where we'll have two different individual masks from our output in this group called Prepare Mask and Image Groups. Then, we bring these two masks, which will import the reference target mask in these custom nodes here. After that, everything is the same for the connections. You can use something called context options, specifically in the Wan Video Wrapper, created for long-length contexts. This divides each chunk of context frames by this number. For example, every 81 frames will be put into one batch, and it keeps generating until the total length of frames ends at the defined number. Let's try that out and see how it goes. Previously, I generated a video where you see the image of two characters, and the outcome looks pretty cool.
Hi everyone, I'm Anna and welcome to our podcast. Today we're going to talk about AI agents. I'm excited to dive into this topic with my co-host Parker.
Hi, Anna, and hello, everyone. I'm Parker. I'm really passionate about AI and its applications in various industries. I'm looking forward to sharing some examples with our listeners.
And don't forget to subscribe to our podcast for more exciting conversations.
You notice details even in the background. There's a monitor, some text, and movement. This is possible because it's an AI video model. However, MultiTalk has some issues after testing it a few times with these AI models for multiple character conversations. For instance, when one character talks, the other sometimes moves their mouth or head unnaturally. It doesn't always clearly identify which character is speaking and who should stop moving their facial expressions. Sometimes when using the MultiTalk framework, this happens. These are some pros, cons, and limitations of each AI, and we should understand there's no ultimate solution for AI models to use. But so far, the performance looks pretty cool. Let's try another image and talk about something else instead of AI agents. In the previous demo I did AI agents, it was just a short demo. You could put topics in this podcast, like what is an AI agent, and it would generate talking conversations explaining what AI agents are in the podcast. Now let's do another topic. What are diffusion models in AI? What can we use them for practically? As you can see, I just put this topic in the text box and it connects to Ollama, where it has predefined text stating that two people are talking. Speaker A and Speaker B have conversations in the podcast, generating the output script like this. We have Speaker A, Speaker B, etc., with rotations of two people talking back and forth, making it more conversational than formal writing. This runs with Ollama, and I'm using Llama 4 Scout. You can try other AI models running locally using Ollama, depending on how much RAM your computer can handle. Most likely, on average consumer PCs, you can handle 7 billion parameter models like Qwen's smaller size model. So I won't explain too much about Ollama. You can check other video tutorials. After that, we'll have the script generated and connect it to Chatterbox. By default, in his workflow, he automatically connected the output text to Chatterbox Dialog. This way is more convenient, but sometimes I prefer to edit before generating the audio. So I output the text dialog here and copy-paste it into the Chatterbox input script. This gives me a more customized way to edit if anything's missing or if I want to add something, but that means it won't automatically run through both AIs at the same time. That's how I do it. If you want everything automated, you can connect the output string here to the input text dialog in Chatterbox. Just connect the line on the top right and drop it. It replaces the input parameters, letting the AI do the job. Afterward, you can modify and edit for further enhancement. Let's try this way. This time, I'll use this image where we have two ladies who love technology, and they'll talk about diffusion models in this podcast script. I've defined two characters here, along with the demo of the voice for Chatterbox voice cloning. First, I'll enable this group. I want to run it step by step instead of running the whole thing, so you can see the difference between what's going on in each step. I manually do it step by step. If you're running it on your own setup, you don't need to do it this way. It's just easier for me to explain what each step does. First, we'll generate the script text using the language model in Ollama, and then we'll generate the audio voice. Let's try this. Once I click Run, you'll see I'm running the Ollama Generate V2 node. This is based on what I input in the text prompt, the predefined system text prompt, and the topic I suggested in this text box. It generates something for me. And it already did that here. It's talking about the AI Explorer podcast, diving into diffusion models in AI. There are two people, Anna and Mia, co-hosts in this podcast, represented by this image of two ladies. As you can see, when I was talking about language models, it's generating the speaker's voice for the two people talking in the chat box using text-to-speech. We can wait for that to generate our result. Meanwhile, as you see, the Chatterbox Dialog TTS is generating now. This is a long context from what's generated by the language model. It's longer than what we usually do, like 1 or 2 sentences. In Chatterbox, it modifies the chunk size using each sentence. If you switch to the command prompt window, you'll see each chunk generates individually and goes through each sentence for each sampling in Chatterbox now. This way, it won't overload the length. In Chatterbox, there's a maximum of 1,000 steps per chunk for audio generation. Once it goes over 1,000 steps, it automatically cuts off the rest of your audio. He made this little modifier for default chunking, so we can have the whole audio as a long length here. The longest one I've tested can generate over 20 minutes without any problem. But, of course, it depends on how well your computer handles it. Now, I've finished my explanation. As you can see, the 3-minute audio is generated already, and there are 2 other generated audios, which are isolations of 2 speakers having their own voices individually generated within that 3 minutes. After the speaker diarization and isolating those voices, you'll see the difference compared to combining 2 voices in one audio. Here's speaker A and speaker B. We'll play each one individually for the beginning part of each audio.
From what I understand, Anna, diffusion models are a type of generative AI model that can create realistic images, videos, and even music. They work by learning to remove noise from an image or data.
As you can hear, speaker A represents Mia, going back to the dialogue of this text script. When Mia is speaker B, she's the second person speaking at the beginning. Then, speaker A is Anna, represented by this speaker voice output here. Let's check out this audio again.
Hi there, I'm Anna, and welcome to our podcast, AI Explorers. Today, we're diving into the fascinating world of diffusion models. Awesome!
As you can see in this section, there's no audio sound from this speaker after we isolated the 2-person audio voices. We can use this for their own different timelines of speaking as the audio output. We've plugged that into speaker 1 audio and speaker 2 audio and passed it into our next step, which is the Wan 2.1 Video Wrapper. We're going to enable this group to generate our video here. Usually, I like to check everything one more time after enabling it and run it again. Let's see the result later after we finish the generations. One drawback of having the language model in the workflow is that sometimes it regenerates the context if you bypass groups, enable groups again, or change settings. This costs a little more time and VRAM for processing. For Chatterbox, it doesn't use too much VRAM in the machine. The audio text-to-speech models mostly support CPU as well. You can enable the CPU option here if you want to use the CPU and just wait for the generations. Let's see how that looks. One thing worth mentioning is that MultiTalk requires quite a long time to generate. For example, here I set it to 60 seconds, which is 1,500 frames to generate. Each 81 frames are divided into chunks of context using the context option. Although it can generate very long lengths, it still takes quite a lot of time to generate here. That's the nature of using this talking avatar framework. As you can see, each step in the bottom section of this log uses memory and generates each frame by frame for the audio here. We'll wait for the generation result and see what happens later. Okay, So we're back to the video now, after generating. As you can see, it took about 19 minutes to generate 1500 frames. Basically, this takes a little while to generate the video, so I suggest you have something else to do while letting it run. We've identified two people here, separating two masks where we're going to use the Wan Video Sampler to generate this video. The output is a pretty casual way, and the overall environment feels like being at home, like a podcast-style conversation. It's just what it is for casual podcast things. We're using 6 sampling steps because we have the Distill CFG LoRa here, which helps us bring down the sampling steps, run faster, and use this method. Let's check out the voice of this conversation.
Today, we're going to talk about diffusion models in AI. I'm excited to dive into this topic with my co-host, Mia.
Hi Anna, and hi everyone. I'm Mia, and I'm thrilled to be here. I've been hearing a lot about diffusion models lately, and I'm eager to explore what they're all about.
So, let's start with the basics. What is a diffusion model, Mia? Can you explain it in simple terms?
As you can see, this multi-talk model, although it says it can do multiple people talking and everything is connected correctly, often the lips don't move responsively to the audio. The reactions of the two different people are sometimes a little off from what you'd expect. For example, when the lady in the black sweater is talking, the other lady might overreact with hand movements and body language. It's randomly generated by the AI itself. But overall, if you don't listen to the voice and just look at the visuals, it looks kind of smooth for an AI-generated video. The consistency is better than what we had in other diffusion models, but it's still not perfect for multi-person talking. As you can see, the performance, honestly, sometimes words and sentences catch on to the character, like this lady here. Here's another example of a talking avatar using two people. This one's a little off, kind of unsynchronized with the lip syncing for two people talking.
Hi everyone, I'm Anna, and welcome to today's episode of our podcast. Today, we're going to talk about something really cool in the world of artificial intelligence, diffusion models.
That's right, I'm Mia, and I'm super excited to dive into this topic. I've been hearing a lot about diffusion models lately, but I have to admit I still have a lot of questions.
If we're not listening to the audio and just looking at it, it looks really natural visually, like two people talking and interacting. But if you pay attention to the audio and the people interacting with it, it doesn't always reflect the actual voices we input into the audio. Sometimes, though, it does catch the lip syncing, like this person here. But sometimes it's way off. Like this person is talking, but their mouth isn't moving. Instead, they're doing body language, trying to express something. As you can see, both people are talking at the same time. So as you can see, when I play this, my mouse points at the one who's talking. Suddenly, when the man is talking, this woman follows the lip sync, and both people are talking at the same time.
I'm excited to dive into this topic with my co-host, Parker.
Hi Anna, and hello everyone. I'm Parker. I'm really passionate about AI and its applications in various industries. I'm looking forward to sharing some examples with our listeners.
And don't forget to subscribe to our podcast for more exciting conversations.
Until next time, stay curious and keep exploring.
This happens because the AI doesn't perfectly identify which person belongs to which voice audio when generating. Therefore, I think a better implementation would be, if it's not the AI model causing this issue, something should let us identify which mask belongs to which audio. For example, we've separated the masks already, so we should be able to say mask 1 handles only audio input 1 and mask 2 handles only audio input 2. This way, we'd have separation of masks rather than passing a bunch of masked as input into the objects. Hopefully, there's a new AI model for lip syncing that supports multiple people identification. In commercial AIs like Kling AI and Runway, they have different identifications. They allow you to highlight specific character and attach that audio to it. That's just my thought. Other than the synchronization of sound for multi-character, the animations is good for how two people talk to each other, and that is the case if you are not hear the audio. Yeah, so that's what I think after testing MultiTalk. You guys can check it out. I'll link Manule's workflow in the description below. See you guys in the next video. Have a nice day. See ya.